Now let's talk about differentiability. Again, this is nothing new that we haven't already studied. Differentiability is basically you finding out the dy by dx of any y is equals to x function that has been given to you. So now we are going to look into the deeper proof exactly of how differentiability we are trying to find out. So whenever we look at any graph that has been given to us, of course, we can say that this graph is continuous at this point. At this point, this graph is continuous. And if our graph is continuous at that point, that means we can differentiate it as well. Only and only if this graph is smooth at that point. Now let's say if I would have a graph which is sharpened at any point, let's say this was my graph, that means I cannot differentiate it at this point, because whenever I differentiate any graph at any point, it is going to give me the slope at that point, which is in this format. Here my angle is theta, so tan theta I can say it to be my slope. This can be equal to dy by dx. This is what basically I'm finding out. Whenever you have, let's say, a sharp edge, a sharp cut in your graphical function, it is continuous at that point, because it is of course showing, it is going to show you and solve all the properties of continuity as well. However, it cannot be differentiated at this point. Now you must be thinking, since it is a sharp curve here, its differentiation is going to be a straight line like this. No, it does not work like that. Differentiation can only be done when you have a graph which is smooth. Whenever it is smooth, only then and only then you can find out this straight line, which is a tangent, I can say, at that point, and that is what your differentiation is. So basically, whenever we need to find out a differentiation of any function, let's say f dash of a, if this is the value that I'm trying to find out, or let's say f dash x, so what can I say? Limit x tending to a, f of x minus f of a upon x minus a. So this is how I find out my differentiation generally. Let's look at a few more properties here. So basically, f of x is differentiable at x is equals to c if this following limit exists. That means my f dash a, as I mentioned above, this should be equal to limit x tending to a, f of x minus f of a upon x minus a. Or I can write this down in this format. If I have, let's say, if I remove this a from here and I replace this by x and h, so it is going to become in this format. So here I would have f of c plus h minus f of c upon h. So whenever you find out differentiation of any function, first of all, there are a few standard things that you already know. For example, let's say if my function is f of x is equals to x, you know that f dash x is going to be 1, right? So what is the proof behind this entire thing? The proof is this one. So basically we use this type of formulas to find out our differentiation. Now let's say if there comes out to be any function whose differentiation you are not being able to find out, so you can use this type of proof to find out your answer. And this another information is that this limit here represents the slope of the tangent line to the graph. As I mentioned earlier, it is going to be the slope of the line that you are finding out. Now, relationship between continuity and differentiability. Of course, any function is going to, if a function is differentiable at any point, it is going to be continuous at that point, because it has to be. We are talking about the curve having a smooth turn. That means it must be continuous at that point. However, the latter cannot be true. That means if, let's say, I have this type of function, or let me talk about the modulus function. Let's say this is my mod x graph. This is continuous at 0, continuous at 0, but not differentiable at 0. Not differentiable at 0, because it comes under a smooth curve or a it comes under a sharp curve or a sharp end. That is why it cannot be differentiated, or the slope cannot be found out for that specific point. Now again, Talking about the geometric interpretation, as I mentioned earlier, as you could have seen in the graph that was drawn in the first slide, no sharp corner at x is equals to c, no vertical tangent at x is equals to c, and the graph should be smooth at x is equals to c. Then only then we can say that our function can be differentiable at that point. Again, there are a few things that you have to keep in mind. Let's say if you have been given a function f of x is equals to, let's say here there is some type of function, here there is another function, here they are saying that x is greater than 0, and here it is for x is less than equal to 0. So what you can see is that, of course, where are you going to check the continuity of this function? At x is equals to 0, because at all other points you know that the function is going to be same. If the function is going to be same, that means the answer is going to come out to be same. The limits and the value at which you are finding it is going to come out to be same. The only point at which you can check continuity is at x is equals to 0. So for checking continuity, what would you do? You would say f of 0 would be equal to limit x tending to 0 f of x, right? And you are going to find out the LHL and RHL separately for 0. Now for differentiation, what happens is that you simply find out f dash x. You simply differentiate these two functions. You, let's say, get something after differentiation, and now you simply check whether f dash 0. Now here the function is of course in the f dash format. Here if this thing comes out to be same, that means you can say your function is differentiable at that point. That means both of these limits have to be equal. Now again, a few rules for differentiability which you already know. Let's say you have been given a sum, so you can simply differentiate it separately, considering the two terms to be completely different. For difference rule also the same rule applies. For product rule, I hope you all remember, let's say if you have product of let me take an example. Let's say you have x into sine x, and you have to find out the differentiation of this. What is it going to become? First you write down the differentiation of first function, which is x, which becomes 1. The second function is as it is, plus then you write down the differentiation of second function, which is going to be cos x, and write down the first function as it is. So this becomes our differentiation. So this is how product rule works. For quotient rule also the same thing is applied. There is a minus sign in between, just remember this sign, and below the denominator gets squared, provided there is one function that g of x is not equal to 0, of course. For chain rule also, if you have g of f of x, then how do you find out its differentiation? It is going to be g dash f of x into f dash x, and this would continue on forever. So let me take an example for chain rule. Let's say if you have e to the power 3x. First of all, you are going to say that this is my g of f of x, and the differentiation, first of all you are going to find out g of f of x. It is going to be e to the power 3x, and as per chain rule, what is your f of x? My f of x is 3x, so what is my differentiation of 3x going to be? It is going to be 3. So this is basically 3 into e to the power 3x. So by chain rule you solve questions in this format. Now let us look at this question. This is a good question, and this would basically clear out all your doubts about differentiability at any points. Now what have they asked us? The number of points where this function is not differentiable. That means the value at f dash x, it is going to come out to be somewhere indifferent. So let us try to find this out. First let us try to simplify this entire equation. If you look at this equation, you can see that this function here, x square minus 5x, this can be written as x minus 1 and x minus 4, and since it is under modulus we would separate it out. So let us write this function in that terms. This would become x minus 1 cos of x minus 2 sine of x minus 1 plus x minus 3 into, this would become x minus 1, and this would become x minus 4. Now you can see that I can take x minus 1 common from these two terms. So if I take x minus 1 common from these two terms, what am I going to be left out with? This would become cos of x minus 2 sine of x minus 1 plus, here I would have x minus 3 x minus 4. Now by the look at this function, of course you do not have to differentiate this entire function. You know this function is going to be continuous. So what we are going to do is we are going to check whether this function is continuous at a few points or not, and based on the continuity we would be able to comment on the differentiability as well. If it is not continuous at certain points, it is not going to be differentiable at those points as well. So that is what we are going to do here. Here you can see that, let's say if I take my x to be 1, my f of x for any 1 plus value, it is going to be positive, because this entire thing would become would open up as positive, right? And if I was to take out f of x 1 minus, it would come out to be negative. So of course I can see that these values are not going to match. And if I look at inside the function as well, whether what is the value, if there is a change in 1, this is not going to get affected, this is not going to get affected, and these two, of course, these are sine and cos terms, these are of course not going to get affected, because whatever be the value of x inside the cos or sine value, it is going to be in the range from -1 to 1. There is not going to be much change here if I take either 1 to be 1 plus or 1 minus, right? If I look at this trigonometric functions, if I was to explain this to you, cos of minus theta, what do I say? This is generally cos theta. And sine of minus theta, what does this value come out to be? This comes out to be minus sine theta. So you can see there is a change here in sine function. For cos it is not going to be a problem. So even if this modulus opens up as positive or negative, we do not care, because cos of minus theta is always going to be cos theta. So basically cos of mod theta is nothing but cos theta. So we can simply remove this modulus from here. That means for x is equals to 2, our function is plain and simple. We can simply calculate its value. It is going to be continuous and differentiable as well. For x is equals to 3 also we can find out the same thing. For 3 plus, for 3 minus, the value does not matter. It is going to be continuous as well as differentiable. The only problem here lies in x is equals to 1 and x is equals to 4. So for 1, as I said, it is going to be positive here, it is going to be negative here, inside here as well. For 1 plus it is going to be positive, and for 1 minus it is going to be negative, because sine opens up in this format, right? Sine of minus theta becomes minus sine theta. So one point we found out, it is not continuous at x is equals to 1. Therefore we can say that it is not differentiable as well. At x is equals to 1. Now for x is equals to 4. Now if I was to check at x is equals to 4, again the same things. You can see that this is going to open up as positive when x is greater than 4, just a little greater than 4, which is 4 plus. And for 4 minus it is going to come out to be negative. That means my entire value would be different. And again I can say it is not differentiable at this point as well. Apart from this, can you find out any other point at which this entire equation seems to be not differentiable or not continuous? No, right? So that means I can say the number of points at which my function is not differentiable is 2. So this is how generally you must solve the questions, be it on continuity, be it on differentiability. You must try to look at the points at which the value of your function might deviate, or it might change from whatever value you are expecting. So based on that, you can find out your discontinuity or non-differentiability points. Now again, these are a few basic derivatives that you already know. Sin x becomes cos x becomes minus sin x, and so on. And you must always remember the condition as well. So for example, let's take sec x. What is its differentiation? Sec x into tan x. Now x should not be equal to pi by 2 plus n pi. Of course, if I take the value of n to be, let's say, 0, and if I take x to be pi by 2, if my x is pi by 2, what is my tan x going to become? It is going to become infinity. And sec x, what is it going to become? It is going to become 0. So 0 into infinity, of course, we do not know what is the value going to come out to be, right? So that is why we generally try to avoid all the values of x at which either our differentiation comes out to be infinite or we do not know, or it becomes an indeterminate form and we do not know how to solve further. So you must keep this values in mind as well. Derivatives of inverse trigonometric functions, again you can have a look at it, remember these derivatives because it is going to be easier for you to solve questions. Again, remembering the tan inverse x and sine inverse x, cos inverse x, these three of course always are the most important derivatives and the most important trigonometric functions, so remember these derivatives as well. Now higher order derivatives. Now once whenever a function has been differentiated, it can be differentiated again, right? So for example here, sine x, what is my dy by dx for sine x going to be? My dy by dx would become cos x, and my dy by dx for cos x would be equal to minus sine x. So since instead of cos x, what can I write down here? Instead of cos x, I can write my function in this format as well. This can be dy by dx, dy by dx of sine x, right? This is my minus sine x. So from here, basically this entire function can be written in this format. d2 y, here y is my sine x, so it is better not to write. d2 by dx square, this would become sine x. So again, nothing much here, simply you differentiate your function twice or thrice, whatever is the number on the order of your order of your derivative that has been given. Parametric equations, again, let's say if you have dy by dx, you can write it down as dy by dt upon dx by dt. Simply differentiate your y in terms of t, x in terms of t, and then divide them. You are going to get your answer. Let us solve this question based on parametric equation, then of course it would become fairly clear as to what we are trying to find out. Let's say if x is equals to 3 tan t and y is equals to 3 sec t, then the value of d2y by dx square. So we have to find out d2y by dx square. So first let us find out what our dy by dx is going to be. So my dy by dx, and since here x and y both are given in terms of t, so I can simply differentiate y in terms of t divided by differentiation of x in terms of t. So what is my differentiation of y in terms of t going to be? This would become 3 sec t tan t upon differentiation of x, this would become 3 sec square t, sec square t. So this is my dy by dx, simply I can cancel out 3 and 3. Now 3 and 3 I've cancelled it out because it is a constant term. It would of course not be affected in my double differentiation as well. Now you must be thinking I can simply cancel out sec t and sec square t, right? However, I cannot do that because sec t is not a constant value. It is going to of course depend on the value of t, right? So I have to find out my second double differentiation, and then and only then I can cancel out my terms. So here first I have to find out my d2y by dx square. So I will differentiate again these two functions separately. So this would become, this is a product rule differentiation. So here it would become tan square t into sec t plus this would become sec cube t. And below what are we going to have? This is going to be a chain rule differentiation. So this would become 2 sec square t, sorry, this would be 2 sec t into differentiation of sec t, which is my sec. So this would become square and this would become tan t. So from here now I can take sec t common and I can cancel it out. So upon taking it common and cancelling it out, what are we left with? Tan square t plus sec square t upon 2 times of sec t tan t. Now let us simply put the value of t to be pi by 4 and let us see what are we getting our answer to be. If I put t is equals to pi by 4, tan square pi by 4, it is going to be 1 square plus sec square t, this would become root 2 whole square upon 2 root 2 into 1. So this becomes basically 1 plus 2, this would become 3 by 2 root 2. This is my answer. So this is how you solve questions related to differentiation in parametric form. Now again, a few more differentiation which you already know. For ln x, it is going to be 1 by x. ln f of x, you are going to apply the chain rule. So 1 by f of x into f dash x. For log ax, when you do not have your base as e, it is again going to be 1 by x. The only thing is that in the denominator, you are also going to multiply with ln a. Now for all these differentiation, I would recommend you all to remember their domains and the value at which they are defined, so that you do not make mistakes while solving question during your exams. For absolute values also, logarithmic of absolute values, it comes out to be 1 by x. There is not much difference here. For product rule, you can find out your answer to be in this format. Sorry, the y is not going to be here. You must remember this. So let's say if I was to solve this type of function, I can either directly take natural log on both sides. Sorry, y is going to be here. I can simply take natural log both sides and then differentiate it. It is going to be come out in this format. Or simply I could have differentiated this function. Now this was a type of logarithmic differentiation that we were doing. For certain questions, you might not be able to directly apply the product rule. So you would have to do it using logarithmic differentiation by applying log on both sides. So this is one of the examples for that. Now the differentiation of exponential functions. E to the power x would simply become e to the power x. E to the power kx, again chain rule, you have to apply e to the power kx into differentiation of kx, which becomes k. So it can be written in this format. With the general base a to the power x, its differentiation becomes a to the power x into ln a. So remember all these different differentiations along with their domains in which they are defined. For a function, again the same thing, you have to use the chain rule. For general base and power, again the same things, you must remember this. Now let's look at this question. Let k and m be positive real numbers such that the function this is differentiable for all x is greater than 0. Now they have told us to find out the value at f dash 8 and f dash 1 by 8. So first of all, if we look at the function, we have an unknown value which is k, we have an unknown value which is m. So we have to find out this. So how are we going to find out this? They have given us this information that it is differentiable for all x is equal to and greater than 0. That means my x for all greater than 0, it has to be differentiable as well as it is going to be continuous. Now the only value at which I have a doubt is 1, because at 1 minus my function is this one, and for 1 plus my function is this one. Apart from this, if I take any other value, let's say x is equals to 8, it is going to come under this function only, whether it is 8 plus or 8 minus. So the value is going to come out to be same. It is going to be continuous there. So I have to check only for 1 minus and 1 plus. Now I do not need to check, of course, they've already given us this, that it is differentiable. That means using the functions of or inequalities of a function being continuous and differentiable, I am going to find out the value of m and k. So for my function to be differentiable at all x greater than 0, it needs to be first of all continuous at x is equals to 1. So if it is continuous at x is equals to 1, what am I saying? That my f of 1 should be equal to my limit x tending to 1. So if I find out my limit here for 1 plus and 1 minus, what is it going to come out to be? Based on continuity, I can say that if I simply put 1 in both the equations, what am I going to get? M plus k square. This value would be equal to 3 plus k root 2. So this is my first equation that I've gotten. I can simply substitute the values of 1 in both the equations, right? Because it is not an indeterminate form. So I can get these values. Now what am I saying is, it also must be differentiable at x is equals to 1. At x is equals to 1. If it is differentiable, so simply what am I going to do? I'm going to find out f dash x. What is my f dash x going to become? It is going to be 6x plus this one would become k, since it's a constant, it would remain outside. This would become x plus 1 to the power minus 1 by 2. And here what are we going to have? 2mx. So this is for x less than 1. This is for x greater than equal to 1. Now for this function to be differentiable at 1, f1 minus and f of 1 plus should be same. So here what I'm going to say is my 6 plus, if I put x is equals to 1 in both these functions, I'm going to get k by root 2. This value should be equal to 2m. I hope I've done it correctly. Yes. So this is my second equation that I've gotten. Now using these two equations, I can simply find out my value of m and k. Of course, I'm going to write it down directly, not waste much time solving it. You can solve it out by yourself. Your k is going to come out to be 7 by 4 root 2 and your m is going to come out to be 103 by 32. So simply what you can do is you can divide this function by 2, put the value of m in this equation, and upon solving for k, you are going to get the value of k. And if you find out k, finding out m is a piece of cake for you. Now what do we have to find out? We have to find out 8 of f dash 8 divided by f dash 1 by 8. So we found out what our f dash function is. So for 8, which function are we going to use? We are going to use 2mx because 8 is greater than 1, right? So this would become 8 into 2 into m into x is my 8 again, divided by f dash 1 by 8. So I would have to use this function now. So here what would this become? 6 into x 1 by 8 plus k times of 7 by 4 root 2 times of x plus 1 to the power. So this can be written down as 1 by, what is my x? 1 by 8 plus 1. So simply you can solve this entire equation and find out your answer. Your answer is going to come out to be 309. So keep this thing in mind, how you are to solve questions of differentiability. You can simply differentiate the function and then check for the limits and the value of that function at that limit. If it comes out to be same, it is going to be differentiable as well as continuous at that point. So this is how you solve this type of questions. Now a few things whenever you are trying to find out differentiation of, let's say, any function which is in this format. So simply what you can do is you can replace x by a sine theta or a cos theta and then try to solve your differentiation, because this would make your calculations much easier. Of course, you can see that root under a square minus x square, you have to apply chain rule, you have to apply the power rule. It is going to be quite complicated for you to solve, right? So what we do here is that we assume that x is equals to a sine theta. So what would this become? This would become a square minus a square sine square theta. I can take a square common, so this would become 1 minus sine square theta, and 1 minus sine square theta is nothing but cos square theta. So this is a square cos square theta. So I can write this down as a cos theta modulus. So I hope you are understanding how we got this basic value. Now finding out the differentiation of this function, it is going to be very easy for you. Now initially what was happening was that my function was defined in x, right? A square minus x square. Now my function would be defined in theta. So dy by d theta, this would become modulus of a cos theta. Sorry, dy by, not dy by d theta. This would be, since this was my f of x, my f of theta would now become this value. And if I have to find out my differentiation, it is going to be in terms of theta, and for initial one, it is going to be in terms of x. So basically these substitutions help you to solve your questions more easily. This is not just going to be helpful for you in solving differentiation, but also when we solve integrations and different advanced calculus questions. So keep this substitutions in mind. Apart from that, the entire theory portion of this chapter is completed. We've talked about limits, we've talked about continuity, differentiability, we've done questions on them. And now we will be looking into a few previous year questions. Of course, there are not much questions that are asked from continuity and differentiability. Majorly the questions are asked from limits. However, I've taken a few questions from continuity and differentiability as well. So that the concepts of those two subtopics are also very much clear to you, and you do not mess up while solving questions during your JEE mains. So let's start with our first question.